So we've spent the last couple of days talking about reflections, and now we're going to move on to a different type of transformation, which we call translations. Okay, so the objective for today is to be able to use the properties of translations and understand what they are. So let's first start with a definition. A translation is a transformation of the plane that slides every point of a figure the same distance in the same direction. Okay, so the two critical properties here is the same distance and the same direction. Okay, so a transformation of the plane is a translation is a transformation of the plane that slides every point of a figure in the same distance in the same direction. So, since distance and direction are so important, we need to have some way of concisely expressing distance and direction so that we can talk more effectively about translations. And the way we are going to express distance and direction is through using vectors. So let's define a vector. A vector is an object that has both a magnitude, which is, in the case of a translation, would be the distance, and a direction. And it is usually represented by an arrow. Okay, so this arrow here would be the way we would normally express a vector. The arrow has a starting point, which we call a tail. The head of the arrow is the arrowhead. The length of the arrow is its magnitude. That's the magnitude of the vector. And the direction of this arrow, this happens to be, I guess you could say, it's sort of northeast. It's sort of pointing upwards and to the right. That is the direction of this vector. But a vector can point in any direction. It can point to the left, it can point down, it can point to the right, or anywhere in between. Anywhere around the entire circle it can point. So the vector very concisely represents magnitude by how large or small it is, and also is able to express direction depending on where it points, whether it points here or there or there. It can express direction. So let's take a look at some of the properties of vectors.